The orders demanded output, and the machines answered with heat and noise. I held the master gauge in my hands, and I knew how little a fraction had to move. When the bottleneck spindle seized, the shop went quiet around it, then pretended it had not. Inspectors came for signatures and causes, and my tools lay clean on the bench. I kept repairing what I had helped to ruin, and said nothing. March 1943. Boulogne-Billancourt, on the western edge of Paris. France is occupied. German authorities control fuel, steel, transport, and labor. Factories that once sold to civilian markets are pulled into the German war economy. At the Renault works on the Ile Seguin, the operational situation is defined by quotas. Trucks, engines, gearboxes, and spare parts are demanded on schedules that ignore shortages. The plant runs under a tense arrangement, when French managers try to keep the factory intact. German procurement officers press for output. Workers move through guarded gates with ration cards in their pockets. This story stays close to the factory floor, not to a battlefield, not to a stab map, to a maintenance bay, a tool room, and a line that must keep moving. The mechanic is not introduced as a hero. He is introduced as a function, a skilled worker assigned to keep machine tools running, to change worn belts, to align shafts, to reset stops and feeds, to keep presses, mills, and lathes within tolerance. In an industrial war, that role sits near the nerves of production. A worker who can stop a line without touching a weapon. A worker who can delay shipments without leaving an obvious signature. His day begins before first shift, when he crosses the yard while the river air hangs cold and damp. He checks the maintenance board for breakdowns logged overnight. He looks for the same patterns every mechanic learns to fear. A repeating fault, a recurring vibration, a motor that runs hot at load. Inside the shops, the sound is constant. Machines clatter. Airlines hiss. Overhead, cranes roll. Foremen watch the clock. German inspectors appear without warning, moving with clipboards and authority. Materials are never quite right. Steel arrives late. Castings vary. Bearings are substituted. Lubricants are thin, stretched, and sometimes improvised. The official doctrine is simple. Keep production steady. Meet the quota. Report disruptions. Do not improvise beyond approved procedures. The lived reality is different. Everything requires improvisation, and every shift is a patchwork of repairs. The mechanic spends more time saving failing equipment than maintaining healthy machines. He is in his 30s, trained before the war. He knows the feel of a proper fit. He knows the difference between a tool that cuts clean and a tool that tears. He knows that 1/10 of a millimeter can decide whether a gearbox will sing or seize. His work is visible only when it goes wrong. When a machine stops and a supervisor demands a name. When a line backs up and tempers rise. When the plant manager is summoned to explain delays that cannot be explained in a single sentence. In early 1943, trouble begins in small, deniable ways. Not with explosions, not with a dramatic confrontation. With faults that look like warware. A drilling jig begins to produce holes that sit slightly off-center, and a reamer chatters when it should glide. A fixture that once held steady now seems to shift under load. A gauge block reads true in one hand and false in another. At first, these problems are explained away. Tools wear faster because cutting oil is poor. Jigs slip because clamping bolts are stretched. Gauges drift because the inspection room is cold, then hot, then cold again. The mechanic listens to those explanations without arguing. He has no need to argue. He understands how much the plant already wants to believe in natural causes. He also understands the weakness of systems under pressure. When schedules tighten, inspection becomes selective. When output matters more than quality, defects move forward. When supervisors fear punishment, they hide bad news. In that atmosphere, the mechanic's access becomes influence. Yet he can touch the parts of production most workers never see. Master templates, reference gauges, stop pins, limit switches, the small components that give a machine repeatability. He is not alone in resentment. Across occupied Europe, factory floors carry quiet forms of resistance: slow work, misplaced parts, worn tools, forgotten, to be replaced. But the mechanic's sabotage is different in scale because it is aimed at the foundations. He begins with adjustments that can be reversed quickly if needed. A stop screw backed out a fraction. A feed rate altered on a machine that already tends to chatter. A belt tension set a little too tight, so bearings heat and fail early. Each act is small enough to be swallowed by the daily chaos. Each act is chosen so that blame will fall on the war, on shortages, on old equipment, on overwork. At the early signs appear as routine maintenance calls. A spindle that should last months needs attention in weeks. A gearbox on a machine tool grows noisy. A motor trips its breaker under load. The mechanic responds with the calm competence expected of him. He replaces what can be replaced. He files reports that say little. He makes repairs that keep the line running, but not too well. The operational problem emerges gradually. Production targets are not met, but not by a dramatic margin. A few percent here. A day lost there. A shipment that leaves late but still leaves. German oversight grows more frequent. The procurement officer arrives with an interpreter and a sharp patience. He points at charts. He points at the clock. He points at the list of vehicles needed at the front. French supervisors pass the pressure downward. A foreman speak more loudly. Breaks shorten. Men and women work through fatigue. The mechanic watches the system tighten. He sees how quickly a factory becomes a machine for extracting effort. He also sees the limits. A machine tool cannot be threatened into cutting true. A worn spindle does not care about slogans. By late spring, failure becomes harder to dismiss. A batch of components comes back from inspection with rejection marks. Not a handful. Enough to be noticed. It triggers arguments at the boundary between shops. Machining claims the fault is in casting. Assembly claims the fault is in machining. Inspection is blamed for being inconsistent. Inspection blames the instruments. The mechanic now has a clearer view of the chain reaction. A small misalignment on a fixture does not only ruin one part, and it ruins every part made until the fault is discovered. It consumes labor twice. It turns scarce material into scrap. He chooses a new target, not a single machine, a reference point that affects many machines. In factories like this, there are masters, master gauges, master templates. Tools used to set other tools. They are handled carefully. They are stored in cabinets. They are trusted without question. The mechanic's routine gives him reason to handle them. He can claim he is checking calibration. He can claim he is confirming wear. He can claim he is responding to inspection complaints. He does not need to steal a master gauge. He does not need to break it visibly. A slight alteration can be enough. A burr raised with a fine stone. a surface kissed too long by an abrasive, a locating face reduced by a fraction. And it is not the kind of damage a hurried inspector notices. Not at once. Not when the shop is loud and time is short. Not when everyone is desperate for the master to be good, because the alternative is stoppage. The altered master begins to do its work. Machines are set using it. Operators trust their setups. Inspection tools are compared against it. A false truth spreads through the system. At first, the parts still fit, because tolerances have some margin. But as the altered master pushes dimensions toward the edge, assemblies become tight. Press fits require more force. Bearings seat with strain. Gears mesh with a pattern that looks acceptable and feels wrong. Assembly workers compensate in the ways assembly workers always do. They tap. They press harder. They use a little heat. They adjust. Those small compensations conceal the deeper issue, until vehicles and engines are tested, until gearboxes run under load, until vibration and heat reveal what paper measurements did not. Returned units begin to accumulate. A gearbox whines too loudly. A bearing runs hot. A shaft shows unusual wear. None of this is unique to Sabotage. Wartime production is full of defects, but the pattern matters. It is consistent. It is clustered around one family of parts. The factory responds as an institution. It does not think first of sabotage. It thinks first of process. Inspection increases. More gauges are checked. More parts are measured. More forms are filled. That response is itself a delay. A factory can produce quickly, or it can measure everything. It cannot do both at the same pace. The mechanic watches the response with care. Yet he does not rush. He does not celebrate. He sees the danger in success. If the disruption becomes too large, authorities will not accept natural explanations. They will look for intent. They will look for networks. They will use fear as a tool. By summer 1943, pressure rises from outside the plant as well. Allied air raids over occupied France increase in frequency. Rail lines and industrial targets are hit. Even when the factory is not directly struck, transport is disrupted. Deliveries come late. Power fluctuates. Night work becomes harder. German authorities respond with more demands. If rail delays reduce supply, they demand higher output when supply returns. If bombing threatens production, they order dispersal and redundancy. If labor is short, they press for more workers, including those compelled through labor drafts. On the floor, the human atmosphere grows heavier. Workers speak more quietly. Rumors of arrests move faster than official notices. A familiar face disappears, and no explanation follows. Within that climate, the mechanic decides on an act that is not easily undone. He chooses a machine that sits at a bottleneck, a large piece of equipment that produces critical components, a machine that, when down, forces work to stop or be rerouted to lesser tools. Such machines exist in any large plant. A boring mill for engine blocks, a grinder that finishes shafts, a press that forms a part no one else can form. He targets the kind of failure that looks like fatigue, not violence, not shattered cast iron, not a smashed control box, a failure inside, a wear pattern, a slow destruction. He knows bearings, and he knows the life of a spindle depends on clean lubrication and correct loading. He knows that contamination in oil does not always show at once. It shows after hours of heat, after days of work. The act is simple in concept and difficult in execution. Contaminate the lubrication path. Not enough to stop the machine immediately. enough to shorten its life sharply. Factories are full of abrasives already, grinding dust, lapping compounds, metal filings. They are controlled, but never perfectly. The mechanic uses a moment when he is expected to be near the machine. He is performing routine checks. He is changing filters. He is cleaning a sump. He is doing what a mechanic does. The contamination is introduced in a way that will not be found in the first hour. It is introduced where it will circulate, where it will score surfaces slowly, and where it will create heat, then more wear, then more heat. The machine returns to work. For a time, it seems fine. The line moves. Supervisors relax slightly. Then the noise begins. A faint roughness at speed, a vibration that can be felt in the floor, a temperature that creeps upward. Operators report it. They are told to continue. They are told to meet the quota. They are told the mechanic will look at it during the next planned stop. The planned stop arrives too late. The spindle begins to mark parts. Finish quality changes. Measurements drift. Scrap rises. When the machine finally seizes, it does not do so dramatically. It does not explode. It simply stops. A heavy silence falls in that corner of the shop. Then the sound of other machines fills the space again. But the bottleneck is closed. Work piles up. The schedule slips. And now the factory faces a particular wartime problem. Replacement parts for specialized machines are scarce. A spindle assembly is not easily improvised. High-grade bearings are not waiting on shelves. The mechanic leads the dismantling because he must. He removes covers. He pulls components. He lays damaged parts on clean cloth. The damage looks like what it is meant to look like. Contaminated wear. Pitted surfaces. Scored races. Heat discoloration that could come from overload. It does not point neatly to sabotage. It points to the conditions of wartime industry. The plant attempts the usual solutions. Regrind. Polish. Replace what can be replaced. Swap in parts from other machines. But the machine is not restored quickly. It runs, then fails again. It produces parts, then ruins them. Each attempt consumes time and attention. Each attempt creates fresh paperwork for German overseers. Each attempt exposes the factory to accusations of incompetence. Production slows in a way that spreads beyond one line. Assembly waits on components. Inspection waits on parts to measure. Shipping waits on complete units. Transport schedules are missed. The official reports change tone. They become defensive. They cite power interruptions. They cite delayed deliveries. They cite workforce strain. Those statements are often true, but they do not account for the stubborn, repeating failure at the bottleneck. German authorities respond with procedure. They call for technical review. They demand explanations in writing. They order stricter controls on tools and materials. They also respond with suspicion, not always stated, but present, because sabotage is known to exist. Because factories in occupied territories are never fully trusted. A security presence grows heavier. Guards appear nearer to the shops. Access to certain cabinets is restricted. Keys are controlled. Movement after hours becomes harder. The mechanic's work now carries a different risk. He is needed more than before because breakdowns are frequent. He is also watched more than before because breakdowns are frequent. The tension between lived reality and official doctrine becomes sharper. Official doctrine demands uninterrupted output. Lived reality produces breakdowns, shortages, and human exhaustion. To reconcile the two, supervisors look for someone to blame. As weeks pass, the bottleneck becomes a crisis. Not a single dramatic stoppage, but a sustained drag. The machine cannot sustain continuous production. Repairs are temporary. Parts are rejected. Rework consumes capacity. The delay begins to measure itself in months. The factory does not cease operating. It continues to make other items. It shifts work where it can. But the targeted flow is disrupted for an extended period. A plant can sometimes compensate for a missing machine by rerouting work. But rerouting creates its own losses. Less precise machines take longer. Operators unfamiliar with a process make more errors. Setups change. Jigs do not fit. The mechanic's sabotage is now embedded in the organization's response. The system is spending its energy on correction rather than output. By early autumn 1943, the strain becomes personal in a quiet way, not through melodrama, through the risk that comes from proximity. In an occupied factory, proximity is evidence. If sabotage is suspected, those who touch the machine are questioned first. Those who maintain tools are examined more closely than those who simply operate them. The mechanic hears that a worker from another shop has been taken for questioning. No charges are announced. No clear reason is given. The absence itself is the message. He does not speak openly of his intent. He cannot. Even among colleagues, words are dangerous. Informers exist. Fear makes people unpredictable. He alters his routine. He spreads his work across different areas to avoid patterns. He answers questions plainly and briefly. He appears as what he must appear to be: a tired, competent maintenance worker keeping failing equipment alive. The turning point does not come with a speech. It comes with a decision under constraint. German oversight orders a deeper intervention. A technical team is requested. Specialists from outside the plant, sometimes from German firms, are brought in to assess the bottleneck machine and the rising defects. Such interventions are disruptive. They stop work for inspection. They demand logs. They compare parts. They check the calibration chain. If the altered master gauge is discovered, it will not be treated as a minor issue. It will be treated as an attack on production. The mechanic understands what the specialists will do. They will trace faults back to their references. They will ask who handled them. They will ask who had access. He makes an adjustment that is as much about survival as it is about sabotage. He helps discover a cause that is plausible and general. He steers attention toward a deficiency that can be blamed on conditions. And he points to contaminated oil as a systemic problem. He points to inconsistent supply of filters. He points to the use of substitute lubricants. These are real issues in 1943. They offer an explanation that does not require a saboteur. They also allow the factory to request materials, time, and parts that will further slow output. A cautious compromise takes shape. The specialists recommend an overhaul, not a quick patch, a full rebuild of the bottleneck machine. Cleaning of lubrication lines, replacement of bearings, recalibration of fixtures, verification of masters and gauges. In peacetime, such an overhaul would be scheduled and resourced. In wartime France, it becomes a long negotiation. Parts must be sourced through controlled channels. Approvals must be obtained. Transport must be arranged under conditions of disruption. Then the line does not restart quickly. The machine is dismantled more thoroughly. Components are shipped out or worked on with improvised methods. Work is rerouted to other machines, reducing output and increasing defects. The delay deepens. It is no longer just the fault of a broken spindle. It is the time required for an occupied industrial system to correct itself under constraint. As the months pass, the factory's social fabric changes. More labor is compelled. Some workers are sent to Germany under labor demands. Others disappear into hiding. The workforce becomes less stable. In such instability, sabotage is both easier and harder. Easier because systems are brittle. Harder because scrutiny increases and trust decays. Authority pushes back in the ways institutions know. Rules tighten. Tool control becomes stricter. Maintenance reports must be signed and countersigned. Random checks become normal. The mechanic is called in more often for explanations. He is asked to account for failures that do not fit neat categories. He does not offer theory. He offers practical observations. He explains that machines are being run too long without rest. He explains that substitute parts do not fit as well. He explains that the shop floor is dirty because cleanup time has been cut. None of these statements are dramatic. They are ordinary truths, and that is their protection. But the institution still seeks a culprit. German security services in occupied France are active. They are aware that organized resistance exists inside industry, including in and around Paris. They know sabotage is a method used to resist forced production. In late 1943, investigations ripple through industrial sites in the region. They do not always find what they seek. They do not always need to. The act of investigating imposes fear and consumes attention. At the plant, an example is made of someone. A worker is removed. Others are questioned. Rumors fill the gaps where facts are withheld. The mechanic continues to work because stopping would be suspicious. He repairs what must be repaired. He restores machines enough to run, then watches them fail in new ways created by the broader stress he helped intensify. The sabotage is no longer a single thread. It has become interwoven with the war economy's own damage. Bombing elsewhere disrupts supply. Rail delays slow parts. Quality declines as skilled labor is drained away. Yet the months-long delay at the bottleneck remains tied to the original act. A contaminated lubrication system and damaged bearing surfaces do not heal themselves. They require replacement and time. Time is the one resource an occupied factory cannot easily obtain. By early 1944, the overhaul finally begins to show results. The rebuilt machine runs more smoothly. Parts begin to pass inspection more consistently. Work moves again, though not with pre-war efficiency. The factory attempts to recover lost months. Shifts are extended. Overtime is pushed. Records are revised. Managers try to demonstrate compliance to German overseers. But the recovery never fully erases the gap. The lost time has already shaped the schedule. Downstream units were delayed. Contracts were renegotiated or redirected. Repair depots waited longer for spares. The mechanics' actions, small at first and then systemic, have done what sabotage in an industrial setting is meant to do. Not a spectacular destruction, a sustained friction, a quiet reduction in usable output. The consequences are not clean. Factories are not clean moral spaces. The workers inside are not all resistors and not all collaborators. Many are simply surviving. Some are coerced. Some are convinced. Some are exhausted into silence. The mechanic's sabotage also carries costs for those around him. Tightened security affects everyone. Increased inspections slow everyone. Collective suspicion makes the shop floor colder. And when authorities respond with arrests, it is rarely precise. As 1944 advances, the operational environment around Paris shifts again. More bombing, more disruptions, more movement of German forces, more uncertainty about how long the occupation can hold. In that uncertainty, the mechanic's influence diminishes. Not because his skill matters less, but because the entire system is beginning to shake. When rail networks fail, production plans fail with them. When fuel is scarce, shipments stop regardless of output. Still, the factory's internal memory keeps the story. Not in official commemorations, but in practical recollections. The months when a key machine would not stay healthy. The weeks when scrap bins filled too quickly. The endless meetings about tolerances and gauges. The sense that the plant was fighting an invisible drag. After the war, institutional responses to such stories vary. Companies rebuild reputations. Governments write narratives of resistance and recovery. Some sabotage is celebrated, especially when it is clearly linked to organized networks. Other sabotage remains unspoken because it sits too close to collaboration, coercion, and the compromises of survival under occupation. For a maintenance worker, there is rarely a medal. There is rarely a clean paper trail. A mechanic's best camouflage is that machines fail all the time, especially in wartime. What can be said with restraint is this: industrial sabotage in occupied Europe often relied on skilled workers who understood systems. They did not need to destroy factories. They needed to waste time. They needed to increase rework. They needed to reduce trust in measurements. They needed to make the war economy spend effort correcting itself. In one factory in occupied Paris, a single mechanic's access to masters, lubrication, and bottleneck equipment helped create a delay that stretched across months. And not by stopping every machine, by forcing one critical stream of production into repeated failure, overhaul, and verification. It is a story about the hidden importance of maintenance, about the difference between making something and making it reliably, about how a worker with a wrench and a gauge can shape outcomes in an industrial war. The quiet legacy is not only the delay itself. It is the reminder that production is a battlefield of procedures, and that the smallest reference tool, altered by a fraction, can pull an entire line off schedule. If this kind of overlooked wartime story is worth preserving, consider subscribing for more documentaries on the forgotten people and systems behind World War II.